The question is, a unity feedback system is characterized by open loop transfer function g of s is equal to k divided by s into s plus 10. We need to find out the value of k so that the system will have a damping ratio of 0.5, and for this value of k, that is which you determine here, for damping ratio 0.5, you have to determine the settling time, peak overshoot, and the time to peak overshoot for unit step input. Okay, so first we'll write what is the given in this problem. Here g of s is given. G of s is k divided by s into s plus 10. This is a unity feedback system, therefore h of s is equal to 1, and damping ratio, that is zeta, it is given as 0.5. What you need to find out is you have to determine the value of k, then you need to find out the settling time ts, and peak overshoot, that is percentage mp, and you need to find out the peak overshoot time to peak overshoot for unit step, that is you need to find out TP. These all you need to find out. Now first we will write the transfer function, that is g of s divided by r of s. That is equal to what? That is equal to g of s divided by 1 plus g of s into h of s. Yes, no? So it is g of s divided by 1 plus g of s into h of s. So we will substitute the value here. G of s is what? G of s is k divided by s into s plus 10. Okay, whole divided by 1 plus g of s is again what? It is k divided by s into s plus 10. H of s is 1, therefore we will not write that. Okay, now we need to solve this. How will solve this? This is equal to k. Okay, k in the numerator, so k as it is. Now here we will take the LCM of this. So LCM of 1 and s plus s into s plus 10 is s into s plus 10, that is nothing but s square plus 10s. You need to multiply here. What you get here? You will be getting this s into s plus 10 as it is, whole divided by, here we will get it as s square plus 10s, that is I am multiplying this, s into s square plus 10s plus k whole divided by this s into s plus 10 as it is. Now these two denominator gets cancelled here, okay, along with this. So here what remains? Remaining is k divided by s square plus 10s plus k. Okay, now what we'll do? We will compare this denominator, that is compare s square plus 10s plus k with what? With the equation s square plus 2 zeta omega n into s plus omega n square. We have to compare this. So when you compare this, what happens? 10 is equal to 2 zeta omega n. You will be getting 10 is equal to 2 zeta omega n, and this k is equal to omega n square. So I'll write it as omega n square is equal to k. Therefore omega n will be equal to square root of k. And here what happens? Here we will find out the value for zeta. So zeta will be equal to 10 divided by 2 omega n. Now zeta value is given in the problem, it is 0.5. So here I'll substitute it as 0.5, that is equal to what? So this will be 10 divided by 2, it is I'll write it as it is 10 divided by 2 into omega n. Omega n is what? It is square root of k. Okay, now if you simplify this, or you can write it as 0.5 is equal to 0.1, sorry, not 0.1, it is 10 divided by 2, it is 5. Okay, 5 divided by square root of k. Now if you solve this, square root of k, that is equal to 5 divided by 0.5. So you will get square root of k, or I'll write the value directly for k. So you will get it as 100. This is nothing but 10. Okay, so you will get the value of k as 100. Now next, what we need to find out? We need to find out the value for omega n. Okay, so here we know the value of k now. Here omega n, if you compare this, you will get now, sorry, if you substitute the value of k here, you will get what? You will get omega n is equal to square root of k. Therefore omega n is equal to square root of 100. So omega n is equal to 10. Okay, now the unit for this is what? The unit for this is radian per second. Okay, now we need to find out the value for omega d. Omega d, it is given as omega n into square root of 1 minus zeta square. Why we are finding omega d? Because here in the formula which we use for TP, that is time to peak overshoot, we need the value for omega d here. So omega n is what? It is 10 square root of 1 minus zeta. Zeta is what? 0.5. So 1 minus 0.5 square. So here if you solve this, you will get it as 8.66. This is omega. Again it is in radian per second. Okay, now you got omega n, you got the value for k, you got the value for omega d. So now we will find the value for settling time. Okay, settling time TS, it is given by 4 divided by zeta into omega n. So 4 divided by 0.5 into 10. This is 0.8. As it is time, this will be in second. So it is 0.8 second. Next, we need to find out the peak overshoot, which will be expressed in percentage. So percentage MP, that is equal to e raised to minus pi zeta divided by 1 minus zeta square into 100, because it is in percentage. Okay, now you substitute all the values here. E raised to minus pi into 0.5 divided by square root of 1 minus 0.5 square, okay, into 100. So this value you will get it as 16.3%. Okay, this is our percentage MP. Now next is TP, that is nothing but the time to peak overshoot for unit step input. That is given by pi divided by omega d. So pi divided by omega d, we got it as 8.66. That is equal to 0.3627 seconds. So this is your problem. Thank you.